Guys, let's go ahead and get started. First off, we're certainly welcome to everyone. We hope you're safe, and this is a good night to spend a few minutes with us just to learn a little bit about light pollution. My name is Dan Ficken. I'm the president of the International Dark Sky of Missouri Association Missouri chapter, and I think we have an exciting program for you here tonight. We're going to be talking about. We actually have some very cool panelists that I'll talk about in just a moment, but our subject is really about Missouri's light pollution, and we're going to be very top level. We're going to talk a little bit about what is light pollution and why do we even care. A lot of people really don't even know what the whole point of worrying about light pollution really is and what we can really do about this. We've got some great panelists, as you can see here on the screen. Dr. Gokhale, I don't know if I pronounced that right. Vayu, I just call you Vayu.
And he's fine.
Yeah, so he's an astronomer for Truman State University, and he's got a really cool project he's going to talk about. Dr. Brett Seymoure is Washington University of St. Louis, and he's an ecologist. I got to tell you what, you get him over a beer, he can tell you some serious stories about moths and bugs and spiders, and it's really fun. And Dan Duffy, I've known for a long time. He's on the city council of the city of Ellisville. And all these folks are on our board, and Dan's got some great stories in terms of working with the public and so forth. So I think we've got a fun program tonight. What we have is about a 60-minute program, and truthfully, I think it could run a little over because we got a lot of great content here, and we started chatting last night, and actually 10, 20 minutes went by very quickly, and it was all kind of fun stuff. Our plan, which we may not be completely on, will be the first 40 minutes is just to go through some stuff with the panelists, meet with them, and then allow the last 20 minutes or so for you guys to ask questions. There should be a little button over there it's either Q&A or chat, I'm not sure which. I'm still not quite familiar with how this works, but if you submit your questions, we'll be able to see those. So the way this works is that you can see us and you can hear us, but we can't see or hear you, and you have to communicate to us through the questions that you're putting in that little chat or Q&A box. And nobody will see your question unless we answer it, and then if we answer it, then everybody can see your question. That's kind of the way it works. Now, that's for the people on Facebook Live. If you're, on Zoom Live webinar, if you happen to be on Facebook Live, which we may have some folks there, you'll be able to watch us and listen to everything, but there's no way for you to actually submit questions. So that's really the way it's going to work tonight, and I'm going to just talk very briefly about IDA. The International Dark Sky Association's been around since, I think, about 1988. And it's really worldwide. It's a global organization, 65 chapters. They have what's called 40 delegates, and they have a number of international dark sky parks throughout. And it's certainly a growing area of research, and you're going to find that we've learned a lot over the last couple of years. Interestingly, there's no real universal definition of light pollution. There's one that you might say that I've seen. It says any adverse effect or impact that's attributable to the use of artificial light at night. And different people will define it different ways. But there are some simple steps that you can do, which we'll talk about that tonight. You can certainly worry about where you place your lights, the amount of light that you put out there, how often whether it's timed or not, whether you put it at the proper times, and of course the proper spectrum of the light can make a big difference on really what causes what's called light pollution. Our Missouri chapter is really a toddler. We're just about a year and maybe not quite 6 months. We were formed in October 2018. We are a 501c3, and we are an official chapter of IDA. We have 14 board members, and we're one of the more active chapters, I think, in actually the country. And so we got a lot of great projects going on. If you explore our website, you'll find out a little bit more about that. And you'll see that we've got our chapter set up in zones. I'm out of St. Louis, and we have at least a couple of board members here out of St. Louis, but Vayu's out of Truman State, Kirksville. But we really are trying to make a statewide chapter. So we've divided up into zones, and we're trying to get board members and research throughout all the different zones. So with that, I'm going to turn it over. What I want to do is I want to have each of the panelists introduce themselves and talk just briefly about the projects that they're working on, because I think that'll give you some context of the materials that we can draw from when we get to the Q&A side of this. So I'm going to first turn it over to Vayu, and he'll talk about this great sky quality meter project that you've got going on. Ready?
Sure. Welcome, everyone. Thanks for joining us. I'm Vayu Gokhale. I've been at Truman State for 12 years now, and I've been working on light pollution related topics for about 5 years. I most of my work is funded by the Missouri Space Grant Association, and it's also supported by Truman State. And the main project that my students and I have been working on is measuring the amount of light pollution by using what are called sky quality meters. And we'll talk about that in the next few slides and a little bit later as well. So Don, if you can go to the next slide, I can tell people how we are looking at this problem. And we have, with my students, determined that there are three important aspects to this project. The first is the one that I just mentioned, which is quantifying light pollution. And the way we quantify light pollution is we measure the sky brightness. And what we really have are these little sensors that measure light. And this is a handheld one. There are automatic ones as well. There's a button that I'm pressing and it then gives you a reading, which I'll talk about in a little bit. So it's very easy to do. It's very intuitive. It's basically a sensor. You have to point up into the sky and it tells you how much light is going into the sensor depending on which direction you're pointing your sensor to. We're also using cameras, just your regular cameras, the digital cameras that you have. You can even use your phones really now. Some of the fancier phones are just as good as some of the cameras. And so that's the research aspect of things. But that's not all. I mean, that's academic stuff that you need your data to kind of back up what you're trying to say. But the things that we're trying to focus on apart from that is to take actions. And both Don and the other panelists will mention or talk about this as we go along, is how do you actually bring about change? How do you fix the problem? So first is defining the problem, then what actions one can take. And to do all of that, then you have to engage in education and outreach, which we do in different ways. I teach classes, so I do bring up light pollution. There's a lab associated with it with my students. And then we also do outreach events at the local planetarium and at the open houses at the local observatory. So if you can go to the next slide, Don. These are the sky quality meters. The one that's shown in the picture in the middle with the 19.66, that one is the handheld version. And then on the left that you're seeing with the two are two sensors that are put in these weatherproof casings. And then you can bring out wires from the bottom, which can then go into a power, then you can supply power that way, or it can go even into a computer and then transmit the data via wireless. And you can get data about your sky brightness in real time, or you can collect data for a week or so and then analyze it later. On the slide, you see what the approximate costs are for this. And for the handheld meter that's shown in the picture in the middle bottom, it's about $130, $135. For the more fancier versions, which automatically collect data, the price can go as high as $350, $370, depending on how many bells and whistles you have with it. But we can get discounts. And what part of our program, which I'll talk about later, involves installing these sensors in these weatherproof casings, and these are battery operated, so you don't need a power supply, across the state of Missouri, so we can get kind of a baseline as to what the light pollution is in various towns across the state. So that's kind of the main emphasis of my project with my students, supported by the Space Grant Consortium and IDA Missouri. If you can go to the next slide, I think we have some more information on our IDA Missouri SQM program. Don talked about the various zones, and you see there's a significant concentration in Zone 2 and Zone 3, basically the St. Louis area, but we're trying to expand out. We have a couple of sensors up here in Kirksville in Zone 1. The Columbia one is still not up, but will get up soon in Zone 6. The one down in Zone 4 is in the city of Ozark. And we have two sensors ready to go in the Kansas City area as well. So there are 10, but there are actually 5 more that we are ready to go online in, say, the next month or so. You can go to the next slide. Okay, here's what the data look like, and there's a lot going on in some of these, so don't worry about focusing on each and every aspect of it. But basically what you have, if you look at the plot on the left, is you get data. Each point there is a data point, and you can get data every 5 minutes or 10 minutes or whatever it is you want. And the initial increase that you see is twilight ending and darkness beginning. And then at some point you see that clouds roll in and clouds reflect back light if there is ambient light going up into the sky because of bad lighting. And then the sky brightness increases and you see the effect of clouds over there. The rest of this particular night in Rolla apparently was cloudy. And I cross correlate these data with the local weather data that you get from, say, the Rolla airport, and it matches out. And so the higher the reading, it's darker, the sky is darker, and then lower the reading on the y-axis, the sky is brighter. The x-axis is just time, don't worry about the numbers there. And on the right panel, you see an animation for, I think, about 3 months, starting about October 24th or 25th, and then going all the way to, I think, mid-Jan, if not early Feb. And you can follow the sky brightness one night to the next, and you see a lot of different signatures in those data, in those plots. And my students and I are trying to analyze what's going on. So if you want to do this kind of stuff, all you need is to install the light sensor in a place where there's no direct light overhead, because we want to measure the sky brightness. We don't want to measure the brightness of the light bulb. So you install it somewhere there are no trees or overhead lights, and then it will just collect data for as long as your batteries last, which is about 3 months usually. And then you can download these data and do this kind of thing by yourself. It's not a very steep learning curve. My students learned it, for example, within a day. And so it's not that hard to do. All right, if you can go to the next slide. I talked about DSLR cameras. And here's a visual. So that's data. Those are numbers, and it requires some training to understand what the numbers are saying. So this is a visual representation of what light pollution really is, how bad can it get, and those sorts of things. So here's a picture I took of the Milky Way in Flagstaff. This is a 5-minute exposure, and I kept my camera tracking so that as the Earth spins, the camera keeps the stars in the same pixels, same position in the camera image. And you see this beautiful Milky Way. You can see the dark cloud band in the Milky Way. You can see all these beautiful stars. You see a lot of pink and magenta colors. Those are all various nebulae in the Milky Way. And this was taken in Flagstaff for 5 minutes. And if you can go to the next slide, Don, you'll see I took a similar image here in Kirksville for 1 minute only. I couldn't even do it for 5 minutes, because if I were to take 5 minutes, it would just wash out into just white. And that white is just ambient light coming from the city. So this is a good visual representation to see how light pollution affects the quality of what you can see in the night. And I have a similar image on the next slide, again, first taken at Flagstaff, where I have not turned on the tracking. So I've kept the camera pointing to the North Star, which is in the middle of the image there, that little dot. And as the Earth spins, then it appears that the stars are going in the opposite direction. So you get beautiful star trails. And you can see these beautiful star trails in Flagstaff. This is a 30-minute exposure where there are no stars. You can see that the sky is more or less black, meaning there is no light coming in where there are no stars. Now let's go to the next image, and you will see what happens if you try to play this game in a place like Kirksville, which is semi-rural. And this is only a 15-minute for the same reason that if I were to take 30 minutes, it would just wash out with white light. And you can see that even when there are no stars, especially to the bottom right, which is northeast from the observatory, which is where Kirksville is, you see all this light coming in from town. So near the wire mesh at the bottom, you can see it's almost white from the light that is coming from town. So you can do this game. Now, modern cell phones can easily take 2, 3, 4, 5-minute exposures even. And so you can play this game yourself. Just put your camera on a stable surface and let it take images for 2 or 3 minutes at one location, go to another location and play the same game, and you can see the difference. So we do both qualitative and quantitative work, and I'll talk about it a little bit later as well. We're trying to get more and more people across the state involved in it. So that's kind of the background summary of my work.
Okay, well, thank you, Vayu. Okay, Brett, let me pull up your slides here. Why don't you tell us a little bit about yourself as I pull up your slides here and get ready for you?
Yeah, sure. Well, yeah, thanks to everyone that were able to join us. And yeah, I'm Brett Seymoure. I'm a postdoc fellow at Washington University with the Living Earth Collaborative. This is my second postdoc experience. A postdoc experience is just a very research intensive situation after someone gets their PhD and before they get a professorship job or another full-time position. So I'll be at WashU for the next 16 months or so. And before that, I was with the National Park Service in Colorado State University in Colorado. Yeah, let's go to the next slide.
Actually, I probably got this slide. Is this the slide you want right now?
No, let's go to the next one.
Okay, got it.
Right, so my entire research focuses around the fact that our Earth has had a pretty steady light environment regime for 4 billion years, that being starting with sunlight and then twilight and then nighttime. And nighttime, of course, varies based on the lunar phase, but this doesn't really change at all, relatively speaking, for 4 billion years. And these animals, all these animals that have evolved over the last billion years, have really tuned in to this difference in light environment. So I started this work during my first postdoc at the National Park Service, and now I'm continuing this with a little bit different focus, and we'll get to that in a second, at WashU. So if you can go ahead and next slide. So this is just my affiliations, National Park Service, and then now I'm with the Living Earth Collaborative, which is a big collaboration between Washington University, St. Louis University, the Tyson Research Center, National Great Rivers Research and Education Center, which is out in Illinois, along with the St. Louis Zoo and the Missouri Botanical Garden. Next slide. Right, so thinking again of the different light environments, there is a huge variation of light that an animal or a human or a plant or anything will be exposed to over 24 hours in a natural situation. And of course, I'm talking more like at a temperate latitude. I'm not talking about the polar regions, which will have pure dark or pure light for a very long time. So the span is about 9 orders of magnitude, which is a billion times difference. And at night, it's very, very dark, and each lunar phase different. So going from new moon to crescent moon to quarter moon to full moon, those are all about 10 times brighter each time you go up. And that's what this figure is showing here. So this is on the x-axis, it's showing the degree of the sun relative to the horizon. So if it's negative, it's below the horizon. And if it's positive, it's above the horizon. And that value over on, I don't know why that got truncated, but the value for the y-axis is just intensity of light. So the bigger the number, the brighter the light environment. So next slide, please. Yeah, and so this is now showing basically a full 24-hour light environment. That yellow line, depending on where the sun is how bright your environment's gonna be. And the whole point of this is that animals have been exposed to this 24-hour regime that varies 9 orders of magnitude. And this is one of the most, it's actually the most reliable cue of any kind of information in your environment. Noise environments, oxygen environments, temperature, all of that varies way more and has varied over the last couple of billion years, unlike light, which has stayed very, very constant. Next slide. This also, this point here just shows that it's not just the actual celestial bodies like the sun or the moon that are changing light environment, but also the vegetation. So if you're under a forest or you're out in a field, you're gonna have a different light environment. Next slide, Don. And I'm just trying to check time here. So now here's the problem. So we have these natural light environments. We have millions of organisms, well, billions of organisms, millions of species that have evolved for specific light environments. And now we no longer have those natural light environments in most areas. In fact, about 25% of the terrestrial Earth surface is light polluted. And a lot of it is urban lighting or parking lots. And that's basically reduced most of the night conditions that an animal would be exposed to. And that's really important. And we'll get into that later on the second part. Next slide.
Oops. Hang on a second here.
Yeah, no worries.
There you go. There you go. I get it?
Oh, yeah. So most terrestrial areas have some levels of light pollution. Next slide now. Okay, great. So that's just kind of going over the main broad question, right? You have these natural light regimes across the planet. Animals have evolved for them. Now what's happening with the fact that we have light pollution, and these animals are no longer exposed to the natural conditions in which they've evolved. The other thing that makes this more complicated and a really interesting question for animals and plants and other organisms is that light pollution is not created equally. And I believe Dan will get into this more technically later on, but we have a bunch of different types of different types of ways of making light, like high pressure sodium, LEDs, metal halides, mercury vapor, and those all have different colors. And you can see here with those two street lights, how you have that orangish one, which is actually a high pressure sodium. And that's what that spectrum, that graph is showing. And then the other one is an LED, which is this more whiter light. To quickly understand these spectra that are on the left, you have the wavelength on the x-axis, and you have intensity of light on the y. So like 300 nanometers would be ultraviolet, 400 is blue, 500 is green, 600 is orange red, 700 is red and infrared. And just notice that, yeah, these different light sources have different colors of light. And so this also means that animals, although they're being bombarded with light pollution, they might be bombarded with different light pollution based on what light sources are nearby. Next slide, please. So a big question I was interested in is whether moths are actually predated more under different colors of light. So if you're a moth, are you more likely to be predated under a high pressure sodium or an LED? And the main question is that a moth under a high pressure sodium is actually going to look different to a bird or a bat, which is going to be eating it, than if it's under an LED. And that's because the different light is actually going to change the perceived color of those moths. Next slide. So we use an army cutworm moth, which was made famous by planet Earth because the grizzly bears eat this. This is actually the fattest animal known to science. It's 73% body fat. For comparison, the fattest whale known to science is about 42% body fat. So this is a very important moth for ecosystems, especially for food webs. Next slide. And what we did is we actually made paper moth models that we were able to tie around street lights, and then we could actually look to see if a bird or a bat has attacked the clay body. So these work really well for understanding predation pressures on moths without actually killing moths. And you can see those red arrows are actually pointing to little marks in the clay. That's where a bird beak has attacked the clay. We mark that as a killed moth. Next slide. So what we found is that under LED, moths are more conspicuous and they're actually predated more, whereas a moth under high pressure sodium becomes more cryptic. Next slide. And so what we have shown is that the different light environments are altering the predation rates. And I can talk more about this, but I just want to show this is kind of where my work goes, is how are animals viewing food or predators in their environment, and how is that changed by artificial light? Next slide, please. So for my current research with the Living Earth Collaborative, I'm expanding this to bigger food webs, trying to understand how different spider predators and spider prey, along with the insect prey, how that's affected by both natural light cycles and light pollution. How's my time? I think I'm going way over. Next slide. Okay, yeah, I gotta wrap this up. So what I'll be doing for the next 2 years is I will, just like Vayu, be using SQMs, which will also be plugged into the IDA database to monitor 24-hour light environments. I also measured the actual spectral component of light, both natural and anthropogenic. Next slide. And then I will be sorting and collecting different insects and spiders, all the arthropods basically, out in the forest floor. And this is very cool. So you can actually, you just dig a little hole and ants and spiders will fall into the hole and you can come and collect them. And what we've designed is this wheel under that hole that will switch every 2 hours. So I will have vials every 2 hours showing me what specifically fell at that time. And that way I'll know if a spider fell in the trap at midnight or at 2 during the day. So now I can actually start to see what the different temporal time niches are for these animals, meaning most spiders are not active the whole day. They're active for only a couple of hours. And I want to know specifically what time they're active and then how that's going to be, their activity is going to be altered by anthropogenic light and natural light conditions. Next slide. We also will be using this very novel technique where we can track using infrared videos of different spiders and prey interacting under different light environments, both in the field and in the lab. And then lastly, once I understand which community of insects and spiders are active at different times of day, right, whether it's twilight or daylight or night, and we'll also use this for the behavioral tracking, then I can actually dive into the retinal system, so the eyes, the visual system, and the brains of these organisms to see how their photoreceptors in their eyes are actually dictating when they're going to be active. Once we know that, then we can actually understand how different colors of light pollution are going to be altering their activity patterns. So next slide. So this just shows how we actually go in and do this retinal physiology, where we can measure the ability of different organisms to see specific colors of light. All right. Next slide. Yeah, that's it. Great. I went way over, sorry.
That's all right. All right, so.
Well, I'm next, and I'm Dan Duffy.
Dan is good.
And while Don is getting there he goes.
Yeah.
I'd like to thank everybody for joining us. I'm not an academic. I do have an MBA in research and statistics from the University of Wisconsin. But my reason for being here is I'm involved in city government, and I have been since 2007. I've been involved in various boards and comprehensive plan development, planning and zoning commission, and I'm in my second term on the Ellisville City Council. I even was the interim mayor for a while. I'm also a member of the St. Louis Astronomical Society, and the reason I'm here is because, in my view, city government can really help with addressing light pollution. And we've taken some steps here in Ellisville to actually do that. And I'll talk a little bit about those later. There's three big sources of light pollution. There's public lighting in streets and parks. This is one way of breaking it down. Public lighting in streets and parks. There's commercial lighting, your auto dealerships and your strip malls and things like that. And then there's residential lighting. And the first two are pretty far and away the biggest sources. Commercial lighting and public lighting. Don, if you go to the next slide. So there's a lot of different ways that commercial lighting can be controlled. And we've tried to do some of those things here in Ellisville. I mean, number one, we can aim it down. Number two, we can recess and shield the lamp. Number three, we can require that our commercial businesses don't emit light above 90 degrees. So there's no upward lighting. It's all parallel to the ground or lower. We can require that our commercial businesses have no illumination at the property line. In other words, all of the lighting is directed down and directed on their property. We can ask them and legislate to have the ordinances or have the fixtures turned off within 1 hour of closing. There can be some exceptions here for security lighting, but security lighting can be an awful lot less intensity than the normal output. And the other thing is we can lower the whole thing down. We can have light standards that are 20 feet or less in height. And just as by way of introduction, I've only got one other slide on this introductory part. And if you go to that, Don, I just want to show the differences between two approaches here. The fixture on the right is near my house, and I tried to get a night picture of it, and I just couldn't get a decent view of the illumination from it because it doesn't really. You can see it's got a hat on it. It's directed down. The bulbs are recessed. It's low, and on the left are a couple of high-intensity LED lights in another part of the city, and you can see what's going on here. The light is basically going every direction. It's creating a lot of glare. And given that these lights were recently changed from sodium to LED, they probably have too many lights too close together, given the intensity of the lights. However, there are a couple of things about LEDs that we'll get into later, that make this problem perhaps more manageable. And that's really all I have to say via introduction, and we'll talk more about what can be done about lighting in a later part. Thank you. Don,
Don's muted.
Don, your microphone is off.
Yeah, thanks, guys. Sorry about that. I was trying to be polite and mess myself up. So our next step is really to address three basic questions from the panelists. And this is really basically, what is light pollution and why do we care and what can we do about this? And what we've done is we divided the questions up between the three folks. And I want to actually start with I guess, Vayu, I'm going to start with you, I think, and let's
Sure.
just talk a little bit about what is even light pollution, and how does it really work?
Sure. So Don mentioned earlier that there isn't one strict definition of what light pollution is, because the main reason we can't quite define it is because there are different kinds of light pollution. And so depending on what problem either you yourself have, either right in your neighborhood, the neighbor's light or something like that, or in your community, in the city or outdoors, you have to look at different aspects of it and then address it accordingly. So if you go to the next slide, I have a couple of examples of what light pollution is. And one way of defining light pollution is basically any kind of outdoor or indoor lighting that is wasted. It performs no function whatsoever, is light pollution. And two examples of this kind of wasted light are either sky glow, so the light going up into the sky and you see the sky glow, especially when it's cloudy, and the other is glare. And a classic example of glare, not related to street lights or fixed light, is lights when you're driving, and then the vehicle coming from the other direction has their high beams on, and now they even have LED lights on especially on trucks, and then they go into your eye and it essentially blindens you. It glares in your eye. And there are street lights like that as well. And so that's two examples of light pollution, if you will. And like I mentioned, it's basically artificial light that we, mostly humans, have introduced into the natural environment, which goes where it's not supposed to go. So for example, the neighbor's light shining into your yard or into your window is an example of light pollution. And like I mentioned earlier, light that goes up into the sky. So again, depending on what kind of situation you have, either in your neighborhood or your town, city, or state park or local park or whatever, there are different aspects to light pollution. And then correspondingly, you have, in some sense, different ways to solve these problems, which we will talk about a little bit later. Okay, if you can go to the next slide. So now that I've defined light pollution, I'm going to go back a little bit and talk about a little bit about the astronomy aspect of things. The astronomers and people who work in the light pollution field have this scale called the Bortle scale. And again, you don't have to worry about the details, but basically the Bortle scale goes from 1 to 9. And the smaller the number, the darker the sky, which is shown in the graphics on the left there. So again, if you look at that Milky Way picture that I showed you earlier, you can then categorize depending on how well you can see the Milky Way, for example, meaning how well you can see the stars at night. If it's an exquisite dark sky, you find some of these skies, as Brett would second, is in national parks and out in the wilderness. You can see the Milky Way very clearly. You can see lots and lots of stars. One way I like to think of light pollution, or really dark skies where light pollution is very minimal, is if you know your constellations and you go to a really dark sky, it takes you a long time to identify the constellation because you see so many stars that you normally do not see that you get confused. And if that happens, that's a really dark sky. That you can count as Bortle scale 1, and then correspondingly it goes higher and higher as the skies get worse. My guess is most people living in the suburbs of St. Louis and Kansas City and Columbia, even relatively smaller towns like Kirksville, are somewhere between 5 and 9. If you go outside the city, maybe another 5-10 miles, you might start going towards 4 and 3, and then really dark skies would be 2s and 1s. The 2s and 1s that I've experienced really are in deserts, in Utah, in Arizona, Badlands in the Dakotas. That's where I've seen 1 and 2 type skies. Most of us are probably familiar with 5 and above. And if you go camping and hiking, you might have seen 4s and 3s. The sky quality meters that Brett and I talked about earlier, these guys, and the guys that go into the weather casings, that scale is given there as well. And it's a little counterintuitive. In the case of sky quality meters, the higher the reading, the darker the sky. And again, most towns and cities and suburbs, you're looking at numbers like 17, 18, maybe 20. And then when you get to the state and national parks and really dark skies are about 22. The darkest sky that can be measured by this meter, there are darker skies, but the darker skies that can be measured by the meter are about 22 in these units. So that's the way you quantify light pollution, if you will. So there's at an intuitive level, you kind of know what light pollution is, but how do you actually measure it? How do you quantify it? These are the two ways of doing it, the Bortle scale and then the sky quality meters. There are other ways as well, but these are the most popular ones. If you can go to the next slide. I'll talk a little bit about our Missouri program. There's another way of measuring light pollution, and that is using satellite data. So you have satellites up in the sky looking down on the earth, and I'll show you a couple of pictures in the next couple of slides. And these are various parks across the state. You can find this map on the Missouri IDA website. So you can zoom in, zoom out, click on a park that is near your town or whatever, and it will show up, a pop-up will come up with various readings from sky quality meters as well as satellite data. And so you can see the different Bortle scales for the different parks. You can see the parks near bigger towns like Jeff City or Kansas City, St. Louis, you see more yellows, and the color coding is on the left. Yellows are brighter skies, more light pollution. And then the darkest skies, as you can see, are towards the southeast of our state. And you can see the black teardrops over there representing really dark skies. So we can go to the next slide, where I have one of these satellite maps of, I think, the United States. You can clearly see a division there. You can see the east part of the United States and then the west part. Once you go halfway across Kansas, you start seeing on I-70, for example, you start seeing lesser population, more desert-like environment until you hit Denver, if you will. And then you see areas of Utah, Arizona, Nevada, which are New Mexico, which are really dark. The East Coast, as you can see, the New York City area, Baltimore, Washington, D.C., that whole corridor between New York City and Washington, D.C. is kind of a lost cause. It's just incredible how bright it is. And I'll just mention that it's worth noticing that these areas are extremely bright, doesn't necessarily correlate with these places being necessarily safe. And this is a point that will be brought up later as well. So, but just to bring it up because you can see it visually over here. On the next slide, I think I've zoomed into our state. And again, this map, the link is on the PowerPoint, which will be made available, I think, on the Missouri IDA website. And again, you can zoom into Missouri, and you can identify the kind of cities pretty easily. You can identify even interstates and highways pretty easily. I'm up in Kirksville over there towards the north, and you can see the string of beads that goes along 63, Kirksville, Macon, Moberly, Columbia, Jeff City, Rolla, et cetera, et cetera. And so you can easily measure light pollution from the satellite. These are satellite maps. They're color coded so that we can recognize what's going on. And again, you see towards the bottom right of that image near Mark Twain, or one of the Mark Twain national forests, you see the black or dark gray color, which indicates darker skies. So my students and I are using some of these data as well. So we're using the sky quality meter data that we're getting from 10 and eventually 15 different locations across the state. And then we are using the satellite data. And you can go to this map, and if you click on it at any random location on the map, it will tell you the nearest readings that they have from the satellite image. And also if there are SQM readings, sky quality meter readings, you can see those as well. So in terms of quantifying the problem, there are various ways of doing it. And as far as IDA Missouri is concerned, we are on it. We're doing it in terms of at least the state of Missouri. There's more to be done. There's a lot to be done. In fact, we want long time base as well. What does the sky look like now? What does it look like 2 years from now, 5 years from now? What did it look like 5 years ago? So we're doing that kind of time-based analysis as well, but obviously that takes time. So that's kind of my work. That gives you an idea of what light pollution is and how we measure it. And I think then Brett can tell us why do we care so much as we go to the next part of the webinar.
Great. So in fact, we are going to go back to Brett, and why I'm bringing up his slides, what I would like to do is ask if you have a question, just to type it into the Q&A. That does is it puts it onto a list for us, and we'll be able to address those right after our presentations here. So, all right, how about that?
Good. All right, excellent. Yeah, thank you, Vayu. That was a great introduction to light pollution. So why do we care about light pollution? I'm trying to say we here, and of course, this is what came into my mind, and this is not an exhaustive list, but yeah, please, Don. Yep, let's show those. So I think I broke it down into three main reasons of why we care. I think we care about the night skies. I think we care about energy, and I think we care about life. So we'll first talk about night skies, talk about energy, which both of those I cannot wax poetic about, but the life one I definitely can, being a biologist. So yeah, going night sky visibility, as Vayu already really did a nice job introducing the boreal sky. We care about the night sky for both just the pleasure of being able to view the night sky. Wait, go back. Is it timed? Are
I think this is actually, I don't know if it's time to read. We're not, but it's not, I'm not moving it.
Oh, weird. Okay, but we'll have to, I guess you might just have to go back every time. That's annoying. I didn't time it. That's weird. Yeah, so, but maybe it's telling me to hurry up. That's probably.
No, sorry. That's not a hint.
Yeah, so the night sky, so much of our science depends on actually being able to measure the night sky, right? Astronomy, cosmology. That all depends on the ability to actually look out into the universe. With poor night skies, we can't do that as well. So we're actually going to lose our ability to study a lot of physics. And that, of course, is very problematic. NASA, right? All these things, that's a huge deal. And a lot of people, when I talk to them about light pollution, a lot of them will talk about when they were a kid, they can remember seeing the Milky Way. There's also something to be said for inspiration of just night sky, just viewing the night sky, sharing a night sky view with someone else. I mean, we probably all have that one moment that we can think of when we could see certain stars or being able to see that constellation for the first time. So it's very powerful to actually have that. And I mean, I do think it's a right to be able to see the natural night sky. That's something we should have. So that's night sky visibility is very important. Next slide. Then the other one, so energy. This is another one that's very big. And again, I'm not an expert on, but a lot of people could go on for days about how important it is for energy. Next slide. So this is just a case in point. There's a lot more to energy than just streetlights. Of course, a lot of residential houses use light, that they produce light pollution. A lot of industrial parks, commercial parks, all these things are producing light pollution. But let's just go with 33% of street light in the United States is directed to the sky. And as Vayu already said, like that's clearly light pollution. There's no reason to be illuminating the sky. Sky doesn't need light, right? Doesn't need it. Light pollution light should be directed down on the ground where it's used for humans. So 33% of streetlights directed to the sky. Next slide. There are 26 million streetlights in the US. Next slide. So calculating that out, for 33% of one streetlight, and you multiply that by 26 million, we have about 22,000 gigawatt hours that are wasted, which, next slide, which means that's about 2.2 billion US dollars wasted every year. $2.2 billion is a big number, so I just did some quick calculations to see what that would really mean. Well, the National Park Service budget in 2018, next slide, please, Don, was 2.6 billion. So the amount of light, that's just the amount of energy that's just wasted from streetlights, we're not even talking about all these other sources of light pollution, could practically cover the operating budget of the National Park Service in 2018. I also just, right before this, I did a, whoop.
I'm sorry, I don't know what's happening.
You're good. You can, right here is great.
Yeah.
Another back of the napkin calculation, I looked at, so how many kids are undernourished and starved in the United States? It's about 12 million kids. And I looked at the cost of feeding a kid in the United States with rice and beans is about 50 cents. You calculate that out, it actually takes just under $2.2 billion to feed all 12 million kids for 1 year, for an entire year, right? So this is why we care about the energy. It's a lot of cost for nothing. Like there's no reason. It's just money going up into the sky and being lost and causing other problems. And it's especially causing problems for life. Next slide, Don. So life. So this is where I'm going to get pretty carried away. And of course, this is not exhaustive. There are a lot of things. So let's go to next slide. So I've broken this down to first human health. Here we go. So there are four main issues that I see with light pollution. And again, there are more, but these are the big ones. We know that light pollution, we know that humans at night exposed to light, especially blue light, leads to overeating and improper digestion, which leads to being overweight and obese. We know that. There's clinical studies showing that. We know that. We also know that blue light leads to insomnia and jet lag. This has to do with actually affecting the melatonin levels in your body. We know that. It also affects circadian rhythm effects, which is reproduction, all these other things. We know that. We know in a lot of clinical studies using non-human animals, so like rats and mice, that exposure to constant artificial light, blue light especially, will lead to tumor suppression and big tumors. So this mouse right here, that is a giant tumor. And the only thing that this mouse was exposed to was light at night. Now, of course, I should also caveat that these mice, right, are bred to be able to develop tumors quickly. So don't worry too much, but it does show that, in fact, when you start messing around with melatonin, with blue light, you can have immune suppression and tumor development. And then lastly, which a lot of people have probably felt, I mean, especially when you're driving down the highway at night and you see these really blue LED headlights, there's a lot of retinal discomfort, and it can actually damage your retina as well. So there's visual problems. So that's human health. Next slide, Don. So those are the big ones of human health. Light pollution also affects animal life. So I am currently working on this paper here that's under review. And what we did is we actually went through the literature. We looked at about 600 scientific papers, and we pulled out all the different effects. Sorry, go back. I don't know why it's doing that. The different effects.
It might be that actually you're doing that. I'm not sure. Are you able to control the screen? Because I'm not actually touching anything.
I think it's there was some default setting on my PowerPoint, and it's just doing.
Oh, gotcha. Okay, so I'm not touching it.
Yeah, no, I think it's just the slides at time. So we're just have to go back, and I do apologize for that. I don't know why it's doing it, but so right. So in this study, we looked at all of these different effects, and what you can see on these figures. So the first one on the left is just the different organisms. So this is broken down by the main groups: reptiles, mammals, crustaceans, insects, fish, etc. And down there, those numbers, those are the different light levels. And at that light level, which are basically what I've used here is the natural equivalent. So the black circle is new moon. The next one to the right of that is crescent moon, and then quarter moon, full moon, and then nautical twilight, which is civil twilight, nautical twilights, when the sun's below the horizon. And what this is showing is the different organisms, number of different organisms in that group that have shown to be affected by light pollution at that level. So in that figure on the left, there was 117 different species that have been shown to have negative consequences from light pollution at those different levels. And then over on the right, it's the different types of effects. So we know that it affects vocal behavior in birds. It affects vigilance in both birds and insects, predation and fitness across the board, numerous different classes of organisms are affected by predation and fitness. And you can see the list, right? Activity pattern, community, assemblages, all these things are affected by light pollution. The jury is not out on the negative consequences of light pollution. The data are there, and it's not looking good. Next slide, please. Another one that I don't think a lot of people think of, and this photo is absolutely fantastic to show it. Light pollution affects life as far as plants go, and probably also affects fungus. But you can see this tree here, which is the leaves that are closer to the street light and actually blocking the rest of the tree. Oh, sorry, go back. They haven't dropped yet, and that's because the tree is confused. The leaves that are close to the street light think that it's still earlier in the fall because the photo period, or the day length, is still very long, right? So that street light is still on. The tree's saying like, well, it's still really, really bright out, for 16 hours a day. It must be summer. I'm going to hold on to these leaves. But the rest of the tree is dropping it because it's not directly exposed to that light source. We also know that it affects bud burst. So in areas with higher light pollution, plants will actually start to bud sooner. They will drop leaves later. And there's current research showing that, in fact, the plant physiology is affected by light pollution, with plants not being able to fight off insect herbivory as well under light pollution. So plants are also stressed under light pollution. Next slide. Yeah, and then lastly, why we care about light pollution as far as non-human life is this thing called ecosystem services. And what ecosystem services are, they're a buzz term right now, but basically it's all of the services that we get from the environment that we're not really paying for, right? So like clean water, a lot of food, right? So when you go and pick a wild raspberry, that's the ecosystem service. You didn't pay for it, it's there. And we rely on a lot of this. And a lot of ecosystem services are determined by insects. Insects are greatly affected by light pollution. We have a recent paper showing that. In fact, there are huge declines in insects right now, about 40% decline in insect populations across the world over the last 40 years. It's very, very serious. And we care about this because insects are the main pollinator source for the food we eat. In fact, 80% of the food that we eat is pollinated by insects. Next slide. And next slide down.
Hang on a second, it's working on it. There you go. Oops.
And in fact, even if you're like, well, you know, I don't care about flowering plants, but yeah, 75% of crop species. And in fact, if you're like, well, I'm a strict carnivore, most of the animals that you're eating are also dependent upon insects for their own food. Next slide. Another thing that's really important about insects is that they're in fact their own pest control, right? A lot of insects eat other insects or other animals that are predating our crops. So insects are great for this because we don't have to use poisons in the environment to control. We can actually just use ladybird beetles and sawflies, all these other things that will actually take out pests that are eating our plants. Another really important thing, next slide, is so many people really like, vertebrates, they like birds, they like reptiles. And again, that's a main food source for these vertebrates that we actually care about. Next. Oh, and a lot of cultures rely upon insects too for food. I think this is last. So next slide. Yeah, and then one huge thing that insects are doing, and this is one that really, a lot of these insects that are focused on decomposition are being affected by light pollution, is insects are the trash disposal, they're the plumbers of the natural world. They break down decaying matter, and without them, our world would be filled with death and feces. And again, I bring this up because insects are greatly affected by light pollution, probably the most affected out of any group that have been studied. So this is really important too. Next slide. All right, so here we go. So now I filled in all the life stuff. You can see it's starting to get pretty crazy. And again, I'm a biologist and this is my expertise, so I went a little overboard. But there's one more thing I would really like to talk to and Vayu actually gave a great introduction about that, and that is, next slide, that's about safety. And so many times people will say like, oh, I have to have my lights on, I have them bright, and I have my whole yard lit up because it's for security. And I get that, right? And especially being in St. Louis with the reputation of St. Louis, I get that a lot of people want to have lights on, and my neighbors have lights on. And I've tried to tell them like, well, it's not actually doing anything. It's probably making it worse. Next slide. So we care about light pollution because it actually is a great tool for criminals to use to do bad things. And in these two photos here, you can see you have this terrible light up on the left. It's not shielded. It's just blasting everywhere. And there is a person in that gate. You can hardly see it. Now, of course, this is a photo, but I'll promise you it's not like a photo trick. It's really difficult to see. When you shield that light, you can actually start to detect that person. And there have been studies where with sociologists, they've gone into prisons, they've shown different lighting houses, right? Dark houses, very bright houses. And they've asked these criminals that are break and enter criminals where they would go. And the criminals always choose housing with poor light because they know where they can go for shadows. They know where they can go to blind the actual victim, right? Like, so if you're looking into a really bright light, you're not going to be able to actually see anyone in your yard. So a lot of times security lights are just a gig and they're not actually productive. And as Vayu said earlier, those brightest areas on our map are not known to be the safest areas. And Vayu and the rest of us were talking last night, he said, if lighting at night represented safety, well, then New York would be one of the safest places in the world. Vegas would be one of the safest places in the world. And that's just not the case. So next slide. I think that is all that I came up with last night when I was hear about light pollution. There are more, I'm sure, and I'm happy to, like, if you have some things you want to share in that post, I would love to see them. But I think this is enough for right now. So thank you.
Awesome. Well, thank you. All right.
Okay, so we're running a little bit over. I'm going to take about 5 minutes here, though, because this last part is the uplifting part of the presentation, I think. I first of all want to thank Vayu and Brett for pointing out that light pollution is a problem. It's getting worse, and there are an awful lot of unintended consequences that could threaten the stability of the world in many ways. But I'm here to tell you that I think, that in my experience, there's things we can do about this. And police will tell you that brighter is not necessarily safer, but there is a lot of momentum behind the idea that has been brought forward for the last 100 years or more that brighter is better. And there's that idea is changing, and there's a lot of things we can do to make that change. The first thing that we can do is to look around your own home. If you live in a house, look at your exterior lighting and see what's an issue. Don mentioned earlier the placing of the lights, the amount of light, the timing of them, and then the spectrum. You want to light only what you need. You want to be energy efficient. You want to use what they call warm or yellow light bulbs that move toward the yellow part of the spectrum. And you want to use a timer, and particularly timers in conjunction with photocells, so that the things go off after they're no longer needed. Don, could you move to the next one? Your proper placing of light. This is another example again of wasted light. I believe Vayu and Brett both talked about wasted light earlier, so we don't need to dwell on that. But you see where the X is a typical streetlight fixture that's somewhat directed down, but there's a lot of wasted light to the sides and up. But it's easily corrected simply by using recessing the bulb and directing the light down. Could we have the next one, please? At your home, you should, some of the things that I've done and some of the things many people in my neighborhood have done, they've dimmed things down, they've used timers, and then when they use a photocell, they don't keep it on just the photocell. The photocell brings the lights on at dusk, but there's a timer associated with that photocell that turns it off after a selected amount of running time. And you can get these timer photocell combinations at Home Depot or Lowe's for like $10, and they'll control all your exterior lighting. Next slide, please. With regard to the spectrum, we haven't talked a whole lot about that, but I would just say that we want to move toward for reasons that were articulated by both Brett and Vayu, we want to move toward the yellow part of the spectrum and stay away from the high intensity, higher temperature lights. The temperature scale is really kind of a misnomer here, but we want to stay with more of the yellow types of lights. Next slide, Don. Fortunately, on most of your light bulb packaging, you can see in the central part here where the red circle is the light appearance, and you want to be toward the warm, toward the warm part of that scale. Most lighting also tells you the measurement of light output in lumens and the number of watts that are consumed. And we really, when push comes to shove, since I talked earlier about how commercial lighting and public lighting are really the largest sources of light pollution, the next slide kind of articulates really where the action is with regard to this, in my opinion. First and foremost, we want to control the amount of light outside your home if you live in a residential home. You want to make sure it doesn't leak beyond its intended areas and use timers, as we've just reviewed. But I have found a lot of receptivity in local city governments to putting standards for public and commercial lighting. And I have some examples of some of those standards, and I believe Don is putting together a group of lighting ordinances that are on the Dark Sky website. Is that right, Don?
Yeah, we started that. We're just beginning to identify.
Okay. Well, I know Ellisville's are on there. Your city does something called a comprehensive plan. Most cities do them every 3 or 4 years. And here is where you can put something into the city planning process that will become a guiding principle for decision making as decisions about lighting come up. Many comprehensive plans don't even mention lighting. But if in the next iteration of your city's comprehensive planning process, you get involved, you can bring lighting to the forefront of the considerations in the comprehensive plan. This is where your zoning is done, and you know, you're planning for commercial districts versus residential districts and things like that. If you contact your city and ask for the planning department and volunteer to participate in the city's next comprehensive planning cycle, I guarantee you they will welcome your input. I absolutely guarantee you they will welcome your input. It can get a little tedious, but it produces results. And the next slide. Another source of light pollution is public parks, and most of your local communities have a park board. I think some of our attendees are actually associated with parks tonight, but there's ways to bring lighting to the forefront in your local park board agendas, including areas that could be kept dark for astronomy or for wildlife, and importantly, to turn the lights off when the park is closed. That's something many parks don't do, or do it to a very limited extent. And earlier I showed 2 pictures, one of very, very bright street lighting in a section of the city, and then a much less intrusive set of lighting that's in a different part of the city. And in my experience, electric utilities are often quite responsive to this. It doesn't make any difference to them whether they put in a real high intensity LED light or something that might still be LED but is lower directional and dimmed. It really doesn't make any difference to them. They're less likely to do that, they're very likely to be receptive to you when they're making changes to streets, or when their new sewers are going in, new light standards are going in. And this is why it's so important to have lighting part of your city's comprehensive plan process. Because if it is, as lights are changed out, the new kind of lighting will be put in. And this will take years. It's almost a generational type of change. But if you stick with it for a while and you get involved, it can be very productive. And it has been for me. And lastly, I just want to say lighting is not always top of mind with city councils and planners. It's up to us, I think, to bring these issues forward and be positive and proactive. As I said earlier, it's much easier to put the right lighting in at the start than to change things after the fact. And I want to say thanks for allowing me to participate in this.
All right, well, it's very good. Appreciate, well, that was really great. And you can see how great a job I did at planning all this. We're well over our time here, but I think the presentations are good. We do have a lot of questions, and I'm going to try to address, and I apologize for those who are planning for only 60 minutes. Looks like we're going to run a little bit over, but that's the core of the presentation, but we do have a few questions to answer. We actually had a question before the meeting about what do you do with LED lights, and I can't get help from basically from my neighbors, and I can't get help from my city government. Dan, do you have any thoughts on that at all?
Well, the nice thing about most LED lights is they're dimmable. And once again, if the situation is approached in a positive and proactive manner, kind of what is shown here in the slide that's on the screen, we can get the light redirected. We can get the light shielded. We might be able to get the light dimmed. And with a timer, again, one of these $10 timers from Lowe's or Home Depot or Ace, you can get the thing shut off after a certain period of time. we don't want a light shining in your bedroom window all night and causing all the problems that Brett reviewed earlier.
Yeah, and there are some great resources on the darksky.org. If you go out and you poke around, there's some things about how to talk to neighbors and even suggested letters and approaches. But it's clear from what I've dealt with over time is that you want to go in with a soft approach and not with a hard approach, because you'll just make enemies for the most part.
Yeah, don't bring your lawyer to
Yeah,
the first conversation.
Right. We had one person asking about the camera Vayu. This is directed to you, about the camera that you use to take those photographs.
Yeah. Yeah. So there are trackers that you get on the market. I would recommend that if you're interested in taking the kind of astro pics that I showed earlier, you go to the Sky and Telescope website, and if possible, subscribe to Sky and Telescope. On their website for free, there's lots of information, and then I can contact you, or you can contact me separately, and we can discuss that, because there's a whole plethora of options, and then depending on how much money you're willing to spend and what specific purpose you're using it for, we can then decide exactly what equipment you might need. But I would say good starting point is go to Sky and Telescope and then look for products, and they have product assessments and reviews. Most of them are freely available, so you should be able to check them out. But feel free to contact me. In fact, I encourage that you contact me, and then we can take it forward from there.
Excellent. We had a question about the LED color is different than sodium. Does this reflect more off of the roads? Anybody know the answer to that question?
Short answer is yes, if I may answer that.
Yeah, please.
The main concern, though, is not so much the reflection. The reflection is a concern, no doubt about it. And you know this from experience. Like, for example, when it snows, and then you go to your backyard or front yard, and if there's a lot of light in your neighborhood, the snow reflects it, and then you can see everything very clearly when there's snow on the ground. So reflection is a concern, but the main concern about lighting in general, in terms of the color, is that blue light travels farther than orange or red light does. So even if your light is not perfectly shielded, or even if it's shielded and it's reflecting off the ground because there's snow on the ground or whatever, water on the ground, the red light won't travel as far as the blue light will. And the reason for that is the same as to why the sky is blue in color, or why the rising moon right now is probably nice orange red. It's the same reason. The red light doesn't travel very far, it doesn't scatter as much. The blue light does, and so it travels farther. So there are multiple reasons for using orange red rather than blue light, apart from all the human and animal direct impact it has on our bodies.
To continue that question, they basically said, what are kind of shieldings available to keep the light from going upward? Have you seen any of the shielding, and where do they get that kind of stuff? The shielding of the lights to where they don't go up straight up.
Well, so at Truman State, for example, we are using these dark sky reflectors. They are like a Band-Aid. Like Dan mentioned, you can retrofit things and all that, but the best way to attack the problem is when a big chunk of money has come in, and the city is renovating stuff or rebuilding the sidewalk or what have you, and they're going to change the lighting or whatever. That's when you need to be there telling them, instead of using these kinds of fixtures, let's use these because these are the advantages. So you can retrofit things, but like I said, that's a Band-Aid that will mitigate the problem a little bit. It's not going to solve it. If you want to solve the problem, you just have to wait and strike at the right moment when things are going to change.
And I would add only that LED is here to stay. I mean, eventually,
Yep.
I mean, LED is the future of lighting.
Right.
But we have to remember that we can control the spectrum, and it is dimmable, and therefore, and it can be directed.
Yeah, LED lights, the orange, red LEDs and the blue, white LEDs pretty much cost the same. I am not entirely sure why administrators prefer the blue, white light when there's so much going against it, but
they're told that it's more energy efficient because there's less phosphor put on the LED. But I mean, at the end of the day, it's so minimal. But
it's not worth the trouble, I suppose. But another thing I'll quickly add, and writing on what Dan said earlier, is that it's not as if the city administrators are sitting in dark, smoke-filled rooms plotting to ruin the night sky for the rest of us. Their crime is actually even worse, which is that they don't even think about it. But in some sense, it's easier to fix because you just bring it up and tell them why this is important and what needs to be done. And they are usually, if not always, receptive.
So I've got another question here. And panelists, if you could do me a favor, take a look at the Q&A because I'm not going to just read the questions. I'm going to queue up this one for Dan. This one's for Dan here. And maybe you can look at the next one right after that. So the light trespass ordinances, if any exist, can they be the starting point for statewide legislation, Dan?
Well, we do have commercial light trespass ordinances in our city, and we're not alone. I don't know that we're anywhere close to a majority of cities having it, and I don't know how well it's enforced. That's also a factor. But yes, it certainly can be a starting point for statewide legislation.
Yeah, one of the challenges I've seen is I don't even think we have a good inventory of who has actually light ordinances. I mean, it's difficult for me, for example, as a chapter president to even figure that out. So we're trying to figure out, the best way to collect that data as a baseline.
Well, that's why we have 42 participants watching right now, and hopefully they live in 42 different places, and hopefully they can all contact their city planners. And really, it's just, I just would like to be involved in the next round of comprehensive planning so that we can bring lighting into the comprehensive plan. It's a pretty simple and straightforward process. And we, fortunately, here in Ellisville, we had a forward-thinking city planner, and really she's the one who brought it to my attention and got me interested in this.
Got it. Right. Vayu, you see the next question about the Bortle scale?
Yes,
okay,
I do.
Can you answer that?
Yes, and that's exactly what my approach is. I think that to solve this problem, we will have to start locally, and smaller towns and cities actually have a better chance of fixing this for several reasons. One is that there aren't that many, you're not stepping on that many toes. If it's a smallest town like Kirksville, you pretty much know the mayor, you know the city planner, and there are 2 or 3 main entities that are causing the problem usually, or at least a bulk of the problem. For example, the local university, car dealerships, gas stations. Those sorts of things are fewer, and you usually have access to the people. So you kind of know them personally, or at least you know someone who knows them. So it's easier to approach this problem. And like Dan and Don both were mentioning earlier, you want to take a soft approach, and personal contacts, there's nothing that can replace personal contacts. Like if you know the right person and you know the right way of talking to them, it's gonna help solve the problem. Because like I said, it's not as if there's a malicious intent here on the parts of the people who are causing the problem. They just are ignorant of the problem. So it's easier to fix in places like this. And we have kind of started that process in Kirksville. And I go to Flagstaff twice a year. I know people in Flagstaff who were involved back in the day, 20, 30 years ago, to get Flagstaff certified as the first dark sky city in the country. And if you go to the Flagstaff city website, they have their ordinances and various tools related to how to get this done on their website up there in Flagstaff. So yeah, we are doing that. And even though I mentioned that, New York City and all that is a lost cause, I was kind of being a little glib there. It's not a lost cause. Like Brett said, if you can minimize the amount of light pollution in New York City alone by 50%, that's probably a few $100 million in savings right there. So there are various ways you can approach this. And I think one of the things I like to say is that there are all kinds of pollution that all of us are concerned with these days: air pollution, water pollution, and now there's this light pollution. But unlike these other pollutions like water pollution and light pollution, the solution to light pollution is local. You can solve your local light pollution problem by working with the authorities in your neighborhood. Air pollution, you can't do that. Water pollution also, you can't do that. If New York doesn't recycle, if St. Louis doesn't recycle, if they have industries that are spewing out gases into the air, there's nothing you can do sitting in Kirksville or Jeff City or wherever. But if there's bad lighting in your neighborhood and in your city or town, you can fix it yourself. And so we should do it. If we can't solve the relatively simple problems, how are we going to solve the hard problems?
Sure. Next question is about how about legal grounds in terms of a neighbor that's not working on this? Is there legal grounds to challenge somebody about lights? Anybody? Dan?
Yeah, well, there are legal grounds for just about anything, but it usually gets very costly and very contentious. And
I think it's a little bit about the attitude of the city. I know when I was in Tucson, they actually have an enforcement group down there that actually goes around and measures the light and makes sure that
Flagstaff as well.
are compliant.
well, that's, yes, especially outside of Tucson with all the observatories. But in the St. Louis area, I have not seen a lot of that. I think that almost all of the big lighting problems have been solved with, just with a positive attitude and a light touch. And when you bring the lawyers into it, it can get really contentious.
Right.
I don't have any experience there though with it, and I'm just kind of speaking from the problems that I've seen resolved without getting into the legal system.
Yeah, and we're on a
I
national.
might quickly add, Don, if I may, that
Yes.
the IDA website, I think it's called darksky.org, and then the Missouri IDA website as well. There are brochures and handouts related to some of these topics, like how can you start the process of creating like a neighborhood, night sky group, if you will. So if one particular neighbor is being a bad neighbor in terms of bad lighting, if you can get the other 6 or 7 neighbors in your neighborhood on board and form some sort of a dark sky group, you can in effect put some amount of pressure. You may not be in good talking terms with them, but maybe some other neighbor is. And so if you can get them on board, then you can slowly put pressure on everyone to kind of reform their bad habits, I suppose. But a soft touch is important, and setting up these sorts of little groups to begin with might be the way to go if you do not want one-to-one conflict.
Yeah, that was actually leading into the next question. Somebody was asking, what's the best way to approach local government? And by the way, they thanked us for showing the photo that they had of bright lights in their neighborhood.
Yeah,
So.
I'm familiar with that particular situation, and it's those new LED lights, they can be dimmed, but it's going to be tough to get them out of there, because once they're installed, it becomes tougher to get them out of there. But they can be dimmed. And in answer to the specific question, a citizens group, a neighborhood group, a homeowners association working with the local government is the best way to do it.
Yep.
And I've seen that work in many cases. And working through your city, your council representative, and then going to Ameren to see about solving the problem. I mean, that's the best way to do it. And it requires patience.
Yeah.
It requires patience.
So Brett, this one's for you, I think. This is a kind of a fun one. This person has a 10-year-old daughter that loves the color turquoise. She's hanging lights all over her room at night, sleeping with turquoise, which is blue lights. And he says, is this a bad idea? Is this a dad, I should put my foot down moment?
Right. And I really do. Oh, yeah, you guys can hear
You're
me.
up.
I really do like that question, and I thought about it. So I would say having it on all night is not a wise idea. Again, the data are showing that being exposed to short wavelengths of light, which would be blue and turquoise, while you're sleeping is damaging to your health. And it's several different organ systems. It's not smart. She's 10. We don't know how resilient this is. Like, is it like smoking? If you expose yourself earlier and then change later on, will those go away? I don't know. I would say if she's going to be sleeping, you use a long wavelength, like a red, amber nightlight, and then the turquoise nightlight, have that on before she's going to bed, and turn it off about a half an hour before she goes to sleep. And here's the thing, I don't know what time she gets up, but you can definitely, when it's time to wake up and it's still dark outside, you can turn that thing on and it'll actually help her wake up. So you can still use it, but you might just say like, look, we need to use this more of like when the sun's up, you can have the turquoise nightlight on or the turquoise daylight on. And when it's nighttime, like we don't get to use blue light because blue light's a day thing. That's what I think how I would handle it. And I've handled that with my nephew as well. He wanted blue all the time. And it's like, well, blue, you can have blue when blue is natural, which is during the day. So I think that's how I'd handle it. I would try to reduce any kind of short wavelengths of light while you're sleeping, especially like 30 minutes before.
Okay, the next question. I'm not sure who to direct this one to. Does anyone know if the rural electric co-ops have more downward dusk to dawn lights? Anybody know the answer to that one?
Well, the same fixtures would be available to everybody. So
But do the rurals tend to gravitate more toward those type of lights? Do you know?
I do not know.
Okay. Anybody else have any answer on that one?
No, I do not know either. I've been to a couple of rural co-ops in the neighborhood here during the day, and I'm one of those people who looks up the light fixtures and annoys my wife by commenting on them. And it's the same. It's a mixed bag. Some of them are shielded. I couldn't tell the color obviously because it was daytime. But some of them are shielded. Some of them are not. At least the ones I visited around Kirksville. And I'm guessing it's the same. I mean, human beings are the same no matter where we stay and what we do. It's one of those things that probably didn't occur to most people when they first set it up. And then once it's set up, there's inertia, right? In any system, once it's set up, you like to keep it the same way. And so I'm guessing even though they appreciate the problem a little bit more because they tend to live outside city limits, then it's darker there. So bright lights will shine brighter, if you will, there. They probably appreciate the problem, but they don't know what exactly to do about it.
Okay, next question I think I want to direct to Brett. This is about accent lighting for houses. This person's talking about their neighbor has different colored lights and just what's your opinion? By the way, Brett, this person happens to be from WashU, so their master's degree from WashU, so maybe I can get you to address. What do you think about accent lighting for houses?
Yeah, I think accent lighting for houses is totally fine, assuming that light's only hitting the house. Now, of course, there's still going to be reflection coming off the house, but I mean, the biggest problem right now, I think, is if we just say like, no lighting, no fun landscape lighting, people are just not going to be supportive of the whole light pollution movement. So I do think that people should be able to put the fancy landscaping light on. The key is, if you want to light up your house, the point is to light up your house. So make sure that it's only hitting the house. Don't have it stray into the sky, right? And we actually talked about this last night during our practice run. There are places in Europe that the whole idea is to light up these really historic churches, like in Slovakia. And what people are doing there, because they're so proactive about light pollution, is they will actually make a filter that goes on the light that is the shape of the church. So that when the light's coming out, it's only the shape of the church. It's only hitting the church, not going past the church, right? Can you ask your neighbor to do that? Maybe. I think what I would do is I would just ask my neighbor to like, hey, can you move your landscaping light up a little bit closer to your house so it's only hitting your house and not, shining everything else. That's what I would do. I do think that when people light up trees from underneath, I think that is, it's not okay. I think that's bad. There's animals that live in that tree that are part of the neighborhood, and I think it's just not a good idea. But if you want to shine a light into your own room, you can do it. Just try to make it so it doesn't hit anything else. What do you have to say about that, Dan? I think you probably have a thought.
Well, I agree with you. I think that the worst type of landscape lighting is the stuff that's simply upward directed spotlights. And then, path lights, little bollard lights along paths and things like that, don't create a lot of stray light. And then light directed at specific parts of the house, such as the entryways or the garage entry, whatever, as long as it's focused on that part of the house, that's.
Yeah, totally.
I mean, we're not going to stop that. Let's put it that way.
Right. Yeah, and when we get to that being the main problem of light pollution, that
would be great.
Right.
We're down to just a couple more questions here, and I do appreciate everybody's patience. I think I'm going to direct this one to Dan. They're asking if St. Louis County has any regulations restricting light trespass from neighbors.
I don't know about in residential areas. I just know that in commercial areas that is an issue, and it is legislated in most of the municipalities. I really don't know about the residential areas. I'm sorry.
Yeah.
I can find out.
Yeah. Okay. In fact, that person, if they want to just email us after this, we'll try to.
Yeah, I can find out.
Absolutely. We have one person that has actually three questions, and I think they're all related. Are the color filters available to change the color temperature of LED lighting, especially for lighting already installed? Anybody want to answer
The
that
answer
one?
is yes. I've installed them.
Okay.
Not just at my house, but at many places around the county as part of my pool and landscape arts business that I had for 20 years.
All right, we've got one more question here, and it's a nightscape photographer. It's one of you guys want to take that one? Who feels like they want to take that one? It says, I'm a nightscape photographer. I share your passion to protect the environment from light pollution. Given the numerous warnings of the impact of light pollution, why do you think this problem still exists in the 21st century? Anybody want to take that on?
Well, it is a 21st century problem. We didn't really have this 2 centuries ago because there weren't that many outdoor lights.
Really, this last 100 years, really.
Yeah, and so I think like all of us have mentioned at some point or the other, it's the worst crime you can commit about an issue that impacts a lot of people, is that not even considering it. And it's just one of those things. I mean, even a simple thing as to why do we put lights on lampposts is a historical accident, because you don't want fire, which is what the source of light was 100 years ago, to be on the ground level, because it would, things would catch fire. That's why we put them on lampposts. And we're stuck with it. So, and so it's one of those things, and it's for people like you and us to, in general, to kind of bring up this issue and say, you know what, we've been doing it this way for 100 years, and it was okay. But especially with LED lights, given how bright and directional they are, if you do not direct them in the right direction, if you do not use the correct spectrum, the correct color, which is mostly orange yellow, then it's going to lead to all these consequences that Brett talked about, that there's a whole food chain is dependent on these ecosystems, on these small insects and birds and animals and plants, that it may not show up right away, but it's one of those things that will affect us over the long run. And like I mentioned earlier, it's a local problem that can be fixed locally, and it's a fixable problem. I mean, you can talk about air pollution, and it's a hard problem to fix because people need energy. People need to travel from one point to the other. You can't tell them to stop. It's expensive to buy electric cars as yet, but it's not. In fact, LED lights are cheaper than the usual lights. You just need to get the right color. Fixtures basically cost the same, like Dan was showing, that the power company doesn't care. It's for people like us to bring it up and convince people that it's in their self-interest to just take this into consideration, and the solutions are already available and they are not expensive as compared to what they are doing anyway. In fact, in the long run, you end up saving money, like Brett showed, by using effectively 1/3 the amount of light that you probably need right now, because 1/3 of the light we use right now just goes up into the sky. It's completely wasted. So yeah, in some sense, like I said, it's a 21st century problem, and it requires people like us to bring it to the attention of the powers that be to fix it.
Well, we're getting a lot of good encouragement here from folks chatting over here, telling us thank you and keep up the good fight. We appreciate that, and that's a good message for everyone. We're a fairly new chapter, and help us get the word out. We'd love for you to get involved with IDA, even simply just joining. As simple as that sounds, it's like $35 a year, something like that. It lets IDA on a global basis know that we're actually making some progress here. They tend to give us more resources. We do have another webinar coming up on April 22nd. This will be kind of a fun little webinar. A friend of mine is really good at apps, exploring the night sky with apps, and he's going to give people a tour how to use that thing. It'll be Earth Day, so it'll be kind of a fun little project. If you go to our website, darkskymissouri.org, that's already set up to register. And we'd love to hear what you have in mind. We have some really great expertise. In fact, we didn't even showcase all of them tonight. We've got some folks that are experts in economics, for example, in the area of tourism, things like that. And if you guys are interested in different topics, we can certainly do this. The panel was kind of a little experiment, and is trying to showcase some of the things we have here, but I think we could deep dive into a particular area if that's interests you guys, and we would love to hear you. And I want to thank all the panelists have done a great job. They were very patient with me last night as I was trying to figure out how to do this, and this is our first time to do it, and I guess we didn't mess up just too bad. So thanks a lot, everybody, and We really appreciate you getting involved with us tonight. Thank you again to all the panelists and to all of you for joining us tonight. Thank you very much.
All right, thank you for joining us. Go look at the moon. A full moon is rising as we speak here.
There you go. Yeah,
Natural light.
And
Awesome.
check your own outdoor lightings. For those who are still listening, check your own house and check the outdoor lighting. That's the most important thing you can do after this.
Yeah,
Then what about others?
actually, I was just asked today to participate on a panel to work on a housing audit. You know, so it's an idea global kind of thing. So I'll talk with them later this week about that. So thanks everybody, and good night. Thank you very much.
All right, good night, everyone.
Is it just us now?